All right, everybody. I think it's fair to get started now. Welcome to my presentation. So today I'll be presenting Leica GNSS global navigation satellite systems presented by me. There's me. So my name is Stefan Roy. I've been in the mining industry for about just a little over 5 years now, and that touches engineering firms, consulting firms. I've worked for contractors. I've even worked for underground surveyor in a different province. I've been with NSS for about 3.5 years now, and my title with NSS is that I deal with all the engineering and mining accounts regarding total stations, GPS systems, high definition scanners for above and below ground, as well as different surveying solutions like our monopod system and our wall presence system for resectioning. Today, like I said, I'll be presenting the GNSS systems as well as reference networks, but we do have quite a couple more geosystem products. As you can see here, this is a quite extensive list of just what I'm able to present. But as NSS, as a whole company, we do provide many other different solutions, as in a full mining portfolio through Hexagon Mining, as well as our MOS system. But today, I'll be just presenting the GNSS reference network. So who trusts Leica equipment? I just threw a little list together. This took me 2 seconds of some of our top clients. These are one of our biggest clients that we deal with on a daily basis. Let's get started. Perfect. So what's a GNSS? So like I stated earlier, a GNSS is a global navigation satellite system. A lot of people refer it to as a GPS. So basically, it's a constellation of satellites that are continuously revolving around the planet. As you guys heard or might have heard last week, SpaceX, they just launched a new satellite out in the orbit. That's for somewhat of a different system. That's for internet, but essentially it's the same thing. It's just a satellite revolving the planet. So the satellite obviously transmits positioning and timing to the receiver, and your receiver that you hold in your hand basically transmits you or gives you information about your location. There's currently many different constellations in the sky, and I'm not talking about stars. I'm talking about satellites. So we mainly use the GPS, which used to be called Navstar, which is actually a United States constellation. They take care of it. We also use GLONASS, which is a Russian constellation. And there's 3 others that we don't use too much up here in Canada, but there's Galileo, Beidou, and Navig. But when it comes down to a GNSS system, there's actually 3 different methods that you can use. You got your float or your autonomous GNSS, which is referred to as a non-RTK system. And your 2 RTK systems are either Base Rover or a reference station network, which through us would be either a SmartNet or a cellular setup. So what's a float or autonomous GNSS system? So basically, when you hold your cell phone, when you're driving your car or your truck, or even when you're in a plane, these are all using float or autonomous GPS systems. They're basically just a very low accurate GPS. They're just small modules that are just simply hooked up, and they're giving you a reading of about 5 to 15 meters, just to give you a general accuracy or a general position on where you are. Like I said, they're typically small and compact units, like your phone, your Garmin, or even nowadays your Garmin watches. They have your smartwatches. They have a built-in GPS for runners, bikers, anything like that. They can track you nice and easily. So yeah, who would basically use the floater autonomous GPS? You have hunters, explorers, travelers, runners, bicyclists, and pilots. Believe it or not, pilots actually use just autonomous GPS. They would not use an RTK system to get high accuracy. Planes typically travel 100 meters a second, so having a GPS that only records 1 to 3 centimeters, it would be way too accurate. So an autonomous GPS is just good enough for a plane. So if we dive into the RTK world, so RTK is essentially your corrections, basically. So when you talk accuracy, you're looking at an RTK system. So you're looking at the real-time kinematic system. It's used to enhance the precision of your positional data. So essentially, it uses satellite-based positioning, much like an autonomous system would, through different constellations. So GPS, GLONASS, Galileo, Navic, or Beidou. So that would be your GPS constellations up in the sky. They would deliver centimeter level accuracy to your GNSS user. So we have multiple different systems. So the reason why I put a tractor there is because we actually have it's called machine control. So we're able to provide a solution for road work, a solution for just road surveying, for new construction or even old construction. If you have to fill, if you have to dig or fill, we provide that solution for tractors, graders, backhoes, you name it. But we also provide pull-mounted GPSs as well. But all this would not be possible without the use of a reference network or base station to get your 1 to 3 centimeter accuracy. I personally find the easiest way to really think about all this is basically the triangulation method. So if you only have 2 sides of the triangle, you will not get an RTK fix. So you need all 3. You need yourself, you need your reference network, or your base station, and obviously you need your satellite GPS, or your satellite system. So in an RTK system, there's, like I said, there's typically the rover, which is you or the machine, and then there's always that third party, which is either your base station or your reference network. So if we just talk quickly about the rover, so the rover is typically a GPS on a pole. It's a mobile system, like a tractor, with the user and data collector. The rover is used to receive signals from the satellites and a base station to basically calculate your position. The 3 main models that we use here for construction survey, or even Ontario land surveying or any of that sort, we use the GS07, the GS16, as well as the GS18. These are basically our flagship products, basically the ones that we provide the most. So our main flagship product would be the GS18, and I actually have a short little video. It's about 2 minutes long. It's in a couple slides, but I'll show you that video in just a bit. If we can quickly look at some specifications, so you have, so right here you have the GS07. So the GS07 is just a very basic antenna. It does not have a built-in RTK functionality. It does not have a modem in it. So basically, if you want to use it for any RTK functionality, you're going to have, that's why there's a little asterisk here, you're going to have a specific CS20 data collector. The data collector has its built-in modem in it, so you can simply slap a SIM card in there or connect it to a base, and you'd be good to go. It does not have built-in storage, so there's no slot for an SD card, and all our GPSs have the same IP rating. If we jump to the GS16, so the GS16 is one of our, I'm going to call it a mid-tier product. It jumps up channels, so it's got 555 channels. When I talk channels, that means the amount of strings that you're able to read off the satellite. Any satellite can have any amount of string. So let's say one satellite can have 5, 10 strings, and you're constantly looking at 15 to 20 different satellites. So if you do 20 times 5, you're looking at about 200 strings. So you're basically covered up to 555 channels or strings. With our GS16 and GS18, we're able to provide the SmartLink or SmartLink fill option, which is really neat because let's say if you're working out in the middle of the bush, no satellite, no cell phone service, nothing like that, and you walk away from your base by too far, and let's say you lose your lock, essentially your SmartLink or your SmartLink fill option will kick in at that point and give you a good 10 minutes of extra leap time to work. The way this works is that it actually does not connect to your base station. It'll connect to the WAS satellites that are revolving around the equator of the planet. So these will basically give you your little fill of corrections. Your data collector will let you know that this happened. So essentially, you have about 10 more minutes to finish your work and then get back to the range for your base. All of our GPS, our GS16 and GS18, we're able to provide 3G as well as LTE now for UHF modem. And if we speak quickly about the GS18, basically the main difference between the 16 and the 18 is that we're able to provide a tilt compensating module in it, as well as a calibration-free and it's completely immune to magnetic disturbance. Let's watch the video next. We'll actually explain it quite well. So what they explain here is that the GS18 is basically a GPS that you do not have to hold vertical anymore. They completely got rid of that notion when you're GPS surveying. So as you'll see in this video, it's a totally tilt compensating, it's a calibration-free GPS system. You can see yourself or your pole live right on the CS20 data collector. So if you have to pick up tight spots like this guy here is picking up on the road, you can essentially just have your GPS at a 45-degree angle. It will compensate. I've tested it myself. I actually have my own video on YouTube playing with the GS18, and you're able to pick up your shots at a 45-degree angle. This works fantastic when you're surveying corners of a buildings, in the inside of wells, underneath vehicles. It's a great tool to have. Another great tool is that it does not get interfered by any magnetic disturbances, much like a lot or most GPSs out on the market currently. So if you're working near power stations, near tractors or heavy equipment, your data tends to get pulled or you lose lock completely when you're near magnetic or metallic objects. It's a completely calibration-free unit. There are units on the market right now that you do not have to worry about the tilt. But ours, what outshines all of our competitors is that it's completely calibration-free. The only calibration there is that we send it back to us every year. We're able to check it, but that's it. All of our other competitors, you basically have to hold the GPS unit, and there's about a 10-minute calibration process every single time you use the GPS. You have to. It's quite silly the way you have to do it, but that's the way we outshine. Again, there's no calibration. You slap it on the pole, and you go. Cool. All right. So. In an RTK system, you have, like I said, in the triangulation, you have your satellites up in the sky. You have you as your user while you're holding your GPS. And on top of that, you have the base station. So that's one of them, or one of the tips of the triangle. So if you're putting up a manual base station, it's used for basically RTK fixed GPS position. RTK again is used for centimeter level positioning. So basically, when you set up the base, you're setting yourself up for accurate GPS measuring. So it basically composes of one GPS unit, which is a rover, and then another GPS unit, which is completely immobile. It's sitting there all day on a setup point, which is known as your base. This is used for very remote areas where there's either no cell phone signal, there's no reference network signal, or you can be out in the bush. This works pretty much anywhere around in the world. And it does not require a host or an internet connectivity. So basically, who would use a base, like a e-mobile base and rover system? It would basically be any land surveyor working remote, or any land surveyor looking for 1 to 3 centimeter accuracy. Lots of remote construction or machinery, they would use a base and rover. If you guys notice, most construction sites, if there's no reference network, they will be using a base. Sometimes it's hidden on a control point. Sometimes they'll even find it sitting on a tripod on the side of the road. A lot of agriculture machinery will use an RTK system because they'll have machine control set up on their John Deere tractor or whatever, what have you. They need to know their trajectory of work in their farm, as well as engineering and design. They'll use it in a remote location. So the second base methodology that you can have would be the reference network station. So we use it through SmartNet. So SmartNet is a sister company from Leica, which actually gives us the same level of accuracy as a base system. So the benefit of this is that you do not have to set up a base system every time you go out. You simply slap your GPS on the pole, connect with your data controller, and you're good to go. It's composed of one GPS unit. It's you, the user, which is your mobile rover. So the reference stations are basically permanent structures that provide real-time and 24/7 correction. These are basically used in urban areas, or basically where base can be permanently mounted. So if you have a cellular network, it's perfect because we can actually tap into that cellular network, and your rover will be able to read that cell network and give you real-time corrections. All it requires is a host for the property. So if it's your property or someone else's, with permission obviously, and an internet connection, because that's how we receive the corrections, is through the internet. So who would use a rover on a network system? So again, this list is the exact same thing. Any land surveyor. So if you're working in an urban area, any land surveyor can use it. Construction machinery, agriculture with great internet connectivity, as well as engineering design. So like I said, the list is the exact same thing. Now it just determines if you have cell network or not. All right, so if we just speak briefly about the data collectors for the GNSS system. So we have two of our flagships. So we have one called the CS20, which is actually our preferred. So the CS20 is a nice handheld unit. It's got an anti-reflective screen on it. So in bright sunlight, you will not have a glare off your screen. It works off the Leica Captivate software. It's got a full QWERTY keyboard. It's IP68. Fantastic little controller. Our second controller, this would be more for the CAD guys that just want to be out in the field. They want a nice big screen to play with AutoCAD. We have the CS35, so it's a 10.1-inch tablet made by Panasonic. It's got the Leica Captivate software again, which is a full ACAD compatible software. Obviously pop-up keyboard and your 128 gig internal storage. So if we speak about the Leica Captivate software real quick, so the Leica Captivate software came out a couple of years ago. It's one of the main softwares that we use for either GPS or total station work. It's dominant, so it's a dominant performance through a seamless integration look. It'll infinitely bridge the field to the office, and I'll actually explain that to you in a couple slides. And as you'll see, it's a very user-friendly maneuverability. It's kind of like your phone. It's easy on the eyes, and it has live tips and tricks to help you out through your entire survey process. So when you first turn on your Leica Captivate controller, be it the CS35 or even the CS20, this is your home screen. This is basically where you'll end up. And all these tiles that you see here, they're all scrollable. So you can actually hold your finger down and scroll it, or even at the apps down here, you can scroll. Again, just like your phone or your iPhone, you can just simply scroll through it. So like I said, simple job tiles. You got your title of work. If you want, if you have a camera on your data sector, you can take a picture of your work. So let's say if you're surveying a building, take a picture of the building. So if you don't remember the name, at least you can see what the project was like. You have your 3D Viewer app, which is standard on all data collectors. So the 3D Viewer app is an ACAD file type compatible application. You can fully rotate and pan and side view all the your entire job. So while you're picking up your work, you can view it much like you can on your PC. You can view it in a rotatable 3D view, as well as if you import any ACAD files, you can bring it in there. You can see all your line work. You can see your points. You can see everything. It's great for scanning as well. So if you guys have an MS60, you can have a nice little dense point cloud in the 3D viewer to simply view it. Down here, you have all your application tiles. You can easily hide the apps that you do not use and rearrange to show your most viewed apps. It's nice and customizable. And when I said you can easily bridge the field to office work, this is basically where I was talking about. So you got your connectivity little tab up here, your little @ symbol. So your Bluetooth connection will be found in there. Either you're connecting to a total station or a GPS. You have your Leica Exchange. So what Leica Exchange is that if you are working in the field and you find a mistake, or if there's a modification done on the job that you are, you can simply call your engineers out in the office, and they can live update your controller while you're in the field. Great. You do not have to go back to the office to re-upload new stuff. They will simply upload a file onto your data controller through the internet, right onto your software here. We're full BIM 360 docs compatible, as well as we're able to provide active assist. So what that means is that if you're having issues with your data controller, something's not working out, I'm able to tap into your data controller via the internet and see what exactly is going on. If we can't resolve it here, we have a full fleet of tech supports that we can easily deploy one of them and go see what's going on. If I open one simple app called the Measure app, which is one of the default applications that we give, this is basically your view here. So on the right-hand side, it's nice and simple. Sorry, on the left-hand side, it's nice and simple. You have the point and code info. So basically, you can view all your point information, view all your code information right here on this nice little panel. You can hide it if you'd like, and then you can maximize your 3D viewer. So your 3D viewer, you can view all your data in 2D or in 3D form. And if you simply want to stake out a point or a line, you can actually hold it, say I want to stake this out, and you'd be good to go. Leica Captivate, we offer numerous different application options. So like I said, 3D viewer is a default one, but we have a list of different job-specific applications that will help you to move forward. So if you're working in the road industry, we have a slew of different apps for roads, rails, or tunnels. If you're actually looking just to do, like athletics, or if you want to do like measurements of a long jump, we actually have an athletics app for that. That'll actually measure the long jump. It'll measure vaulting. It'll actually measure all these different little Olympic style things. But on top of that, yeah, like I said, we have many different applications that'll suit your job. And that is it for my presentation, short and sweet. Is there any questions? I just want to point this out. We do have 2 upcoming webinars. So in the next, in 2 weeks from now, I'll be back on presenting our monopod system. We'll join, and I'll basically talk more into that. And then 2 weeks after that, so in about a month from now, Ben will be presenting CloudWorks, which is a HDS software, great for your favorite point cloud manipulation softwares. My contact information is right here. If there's any questions you may have, by all means, send me an email, or that's my cell phone number. You can text me or give me a call. I'll be glad to answer any questions you guys may have. And with that, I think that's the end of our presentation.